Okay, I couldn't remember if we had done a problem like this in the videos and if there was one example in the book. So there are two absolute values in one equation. Okay, so it is an equation. And what I do, the way I do these problems is I take the one on the left, take it out of the absolute value, and then make that equal to the opposite of the one on the right. And then I take the one on the left and just keep it the one on the right. Okay, so a lot of times people want to make on this first equation, they want to make both sides negative. But you don't want to do that because what's a negative divided by a negative? Positive. And so it would be like you didn't change the equation, right? You'd get the same answer. So you want to make sure that you keep one side positive and then change it to negative, to get the two different equations. Okay, so there's a lot of fractions in here. I'm going to show you two different ways to do it. So on the first one, I'm going to say 1/3 x plus 5. I'm going to go ahead and distribute the minus sign. So that's something to remember you need to do there. And then I'm going to go ahead and add the 3/4 x over. You could write it that way if you wanted to. Now, a little bit of fraction review. Okay, so I want to get a 12. So I'm going to multiply by 4 here and 3 here. And so what do I get? I get 4/12 x and 9/12. 4 and 9 is 13/12. Over, yeah. Well, I put the x in the numerator. You could leave it out to the side. It's the same thing. Okay, and then you also want to subtract that 5. And so you're getting that to equal, what, -3? So then I would go ahead and multiply by 12. And divide by the 13. And get one of the solutions. Okay? So that's a solution. They're going to use set notation on that, but I don't remember what WebAssign does. I think they just let you put in the answers. Okay, and then the other one, I don't have to worry about distributing the minus sign because it's not that case, but I'm going to show you a different way to do it. Let's say you're not really big into fractions maybe, and you just want to say, I don't want to deal with the fractions. You could multiply by the LCM on both sides, which is 12. Now what you have to do is you have to distribute that. So you're going to get 3 into 12, 4x, plus, and then 12 times 5 is 60. On the other side, you're getting 4 into 12 goes 3, so you're getting 9x, and then minus 24. Okay, now we can solve it. If I want to keep it positive, I don't always, but let's go that route. I know sometimes teachers will say, oh, keep the variable positive. Doesn't really matter to me, but and then you're going to add the 24 over. So what do we get? 84 equals 5x, or I don't have a room. X equals 84 over 5. Let me go over that set notation just for you so you can see it. So we have two answers in set notation. It's -36 over 13. Again, I'm leaving that as an improper fraction. And the other solution is 84 over 5. So sometimes those problems are a little scary because we get those kind of goofy fractions, but you're going to feel so good when you look at the answer and get it right. Okay, that's the way that one worked.